But this half hour, we're going to show you some extraordinary images of space, and to do them justice, really, you need to see them across.
The James Webb Space Telescope is identifying objects in the dark ages that, by best measurements we have, are large, fully developed galaxies. So who ordered that?
In the vast darkness of space, where light from the farthest stars takes billions of years to reach us, a telescope unlike any other has turned its gaze to the edge of time itself. Built to peer into the universe's deepest secrets, this marvel of engineering has spent years capturing the faint glow of creation, mapping realms no human eye has ever seen. For decades, we've dreamed of glimpsing the universe's infancy, a time when the first stars sparked to life and the cosmos began to take shape. But what this telescope found in a seemingly empty patch of sky has stunned the world. Ancient galaxies, glowing with impossible brightness, structured in ways that defy our understanding of cosmic history. These aren't just images, they're a challenge to everything we thought we knew about the universe's birth. What secrets do these distant lights hold, and could they rewrite the story of creation itself? Before we unravel this cosmic revelation, smash that like and subscribe for more mind-blowing discoveries from the stars. The telescope's mission began as humanity's boldest attempt to see beyond the limits of our vision, its instruments tuned to capture light that has traveled for eons. Designed to detect the faint whispers of the universe's earliest moments, it focused on a dark corner of the sky, a place where no stars or galaxies were expected to shine. Scientists hoped for glimpses of the cosmic dawn, that fleeting era when the first structures formed from the chaos of the Big Bang. What they found was far more than they bargained for, a collection of galaxies, ancient beyond imagination, glowing with a luminosity that shouldn't exist. These weren't the faint, scattered sparks of a young universe, but massive, structured systems, pulsing with the energy of countless stars. The discovery was staggering. These galaxies, their light stretched by the universe's expansion, appeared as they were over 13 billion years ago, when the cosmos was just a fraction of its current age. Yet they were too bright, too massive, too evolved for their time. According to our models, galaxies in the universe's infancy should have been small, chaotic, slowly gathering gas and dust to form stars. But these were different, producing stars at a blistering pace, hundreds of times faster than expected, as if the universe had skipped chapters in its own story. The telescope's data revealed structures that were already complex, with hints of vast networks and clusters, suggesting a cosmic architecture that formed far earlier than we thought possible. What made these findings so shocking was their contradiction of cosmic timelines. The telescope detected traces of heavy elements, carbon, oxygen, perhaps even nitrogen, within these ancient galaxies. These elements, forged in the hearts of stars, shouldn't exist in such abundance so soon after the Big Bang. The first stars, born of pure hydrogen and helium, were supposed to live fast and die young, scattering their ashes to seed future generations. Yet these galaxies suggested that entire cycles of stars had already lived and died, enriching their surroundings with metals in a fraction of the time we thought possible. How could such complexity arise in a universe so young? Were there unknown processes at work, or is our understanding of the Big Bang itself flawed? The telescope's instruments also revealed another mystery: signs of supermassive black holes at the cores of these galaxies. In our nearby universe, such giants take billions of years to grow, devouring matter over vast timescales. But these black holes, already colossal in the cosmic dawn, defied explanation. Their presence hinted at mechanisms we don't yet understand, perhaps rapid collapses of massive gas clouds, or even precursor objects from an era before the galaxies themselves. Imagine a universe where the seeds of destruction and creation were sown in its earliest moments, growing into behemoths while the cosmos was still in its cradle. Could these black holes be relics of a hidden chapter in cosmic history? The galaxy's distribution added to the enigma. Instead of being scattered randomly, as expected in a young, chaotic universe, they formed subtle filaments and clusters, like threads in a cosmic tapestry. This suggested that the vast web of galaxies and dark matter, which shapes the modern universe, was already taking shape far earlier than our models predicted. It was as if the universe had a blueprint, a structure that bloomed with shocking speed, defying the slow, gradual evolution we assumed. The telescope's data painted a picture of a cosmos that was anything but simple, a dynamic, vibrant realm where stars, black holes, and galaxies emerged with a complexity that challenges our deepest assumptions. The scientific community was electrified. For years, we've relied on models that described a universe evolving slowly, its structures forming over billions of years. But these galaxies suggested a different story, one of rapid creation, driven by forces or conditions we can't yet name. Were the fundamental constants of physics different in the early universe, allowing stars and galaxies to form at a breakneck pace? Or did the Big Bang itself leave behind initial conditions, quantum fluctuations, perhaps, that seeded this unexpected complexity? The telescope's images weren't just snapshots. They were a challenge to rewrite the rules of cosmology. The discovery also hinted at a pivotal moment in cosmic history, the era when the universe became transparent, its fog of neutral gas clearing as the first stars and galaxies ionized their surroundings. The telescope detected faint traces of ionized hydrogen and helium in these galaxies, suggesting they played a role in this cosmic transformation. This was direct evidence of a process we've only theorized, a glimpse into the moment when the universe opened its eyes to light. But how could such young galaxies wield such power? The data raised the possibility that the timeline of this era, known as reionization, is shorter and more intense than we ever imagined. As scientists grappled with these findings, the telescope's images stirred a deeper sense of wonder. These weren't just distant objects, they were time capsules, carrying light from a universe that no longer exists. Each photon, traveling for over 13 billion years, was a messenger from the cosmic dawn, whispering secrets of a time when the stars were born. What forces shaped these galaxies? How did they defy the slow march of cosmic evolution? The telescope had opened a window to the past, but it also posed questions about the future, questions that could redefine our place in the cosmos. The telescope's images of ancient galaxies, glowing with impossible brightness at the edge of time, have shaken the foundations of cosmology. These are no mere relics of a distant past. They're a challenge to the very story of the universe's birth. With stars forming at a ferocious pace, heavy elements appearing far too early, and vast structures weaving a cosmic web billions of years ahead of schedule, these galaxies defy every model we've built. What forces drove this rapid creation? Could our understanding of the Big Bang itself be incomplete? And what does it mean for humanity to glimpse a cosmos so vibrant, so complex, in its earliest moments? This discovery isn't just a window into the past. It's an invitation to rethink our place in a universe that's far more dynamic than we ever imagined. The galaxy's unexpected properties are rewriting the rules of cosmic evolution. Their blistering star formation, producing hundreds of solar masses per year, suggests mechanisms we haven't yet grasped. In the modern universe, stars form slowly, their birth fueled by collapsing clouds of gas and dust. But these ancient galaxies, shining just a few 100 million years after the Big Bang, were forging stars at a pace that defies logic. It's as if the universe, in its youth, was a furnace of creation, burning with an intensity we can't explain. Could unknown physical processes, perhaps stronger gravitational forces or denser primordial gas, have driven this frenzy? Or does the fault lie in our models, built on assumptions that no longer hold? The presence of heavy elements, carbon, oxygen, traces of nitrogen, in these galaxies is another cosmic riddle. These metals, born in the hearts of stars, should take generations to accumulate as the first stars explode and scatter their ashes. Yet these galaxies, barely out of the cosmic cradle, already carried the fingerprints of stellar death. This compresses the timeline of cosmic evolution to a staggering degree, suggesting that entire cycles of stars lived and died in a fraction of the time we expected. Picture a universe where the first stars burned so fiercely Their explosions seeded galaxies before the cosmos had time to settle. Could there have been a hidden generation of stars, lost to time, that set the stage for these luminous giants? The supermassive black holes at the cores of these galaxies deepen the mystery. In our nearby universe, these cosmic titans grow over billions of years, devouring matter to reach their colossal mass. But in the cosmic dawn, these black holes were already monstrous, their presence a paradox that challenges our understanding of formation. Were they born from the rapid collapse of massive gas clouds, or could they be relics of an even earlier era, perhaps seeded by quantum fluctuations in the Big Bang's aftermath? It's as if the universe hit a chapter of its history, one where the seeds of destruction and creation sprouted faster than we ever thought possible. What other secrets lie buried in the light of these ancient galaxies? The galaxy's distribution, clustered in subtle filaments and webs, suggests a universe that was already knitting itself together far earlier than expected. In our models, the cosmic web, that vast tapestry of galaxies and dark matter, took billions of years to form as tiny density fluctuations grew into sprawling structures. But these galaxies hint at a cosmic architecture that bloomed with shocking speed, as if the universe had a blueprint from the start. This accelerates the timeline of cosmic structure, forcing scientists to rethink how gravity, dark matter, or even unknown forces shaped the early cosmos. Could the universe have been born with a complexity we've underestimated, its framework etched in the fires of creation? The telescope's data also offers a glimpse into a pivotal cosmic moment, the era when the universe became transparent, its fog of neutral gas cleared by the light of the first stars and galaxies. The faint signatures of ionized hydrogen and helium in these galaxies suggest they were key players in this transformation, known as reionization. It's as if these galaxies were the torches that lit the cosmos, burning away the darkness to reveal the stars. But their brightness and early formation pushed this timeline earlier than we thought, suggesting a more intense, rapid process. How could such young galaxies wield such power? The answer could lie in a universe where the laws of physics operated differently, or where hidden forces drove the cosmos to awaken sooner than we imagined. The scientific implications are profound. If these galaxies formed stars and black holes so quickly, our models of the early universe, its fundamental constants, its expansion rate, may need to be rewritten. The presence of heavy elements and structured clusters hints at a cosmos shaped by processes we don't yet understand, perhaps quantum fluctuations or exotic physics at the Big Bang's edge. Scientists are already revising simulations, incorporating variables like rapid star formation and early dark matter interactions to capture this unexpected complexity. But the truth is, we're peering into a realm where our tools are only beginning to catch up with the universe's grandeur. Speculation about the discovery runs wild. Could these galaxies be evidence of a universe with different physical laws in its infancy, where gravity or particle interactions were tuned for rapid creation? Or do they point to a pre-Big Bang era, where precursor objects seeded the cosmos with the building blocks of galaxies? Some theorists even whisper of multiverse signatures, where the observable universe's edge reveals hints of other realities etched in subtle asymmetries. Each idea pushes the boundaries of science, challenging us to dream bigger, to question the very foundations of the cosmos. What lies beyond these galaxies, at the true edge of time? The discovery also has practical implications for future exploration. The telescope's success in capturing light from 13 billion years ago proves we can peer into the universe's deepest past, but it also raises the bar. Future observatories with even greater sensitivity could uncover fainter structures, perhaps individual stars from the cosmic dawn, or relics of a time before galaxies formed. The hints of gravitational lensing in the telescope's data, bending light from even more distant objects, suggest a universe waiting to reveal more. But to chase these secrets, we'll need instruments that push beyond today's limits, built to capture the faintest whispers of creation. Philosophically, this discovery reshapes our cosmic perspective. For centuries, we've seen the universe as a vast, static canvas, its history unfolding over eons. But these galaxies reveal a cosmos alive with energy, its earliest moments bursting with creation. It's as if the universe was a theater, its first act played at a pace we never imagined, with stars and galaxies taking the stage before the curtain barely rose. This telescope, a marvel of human ingenuity, has given us a front-row seat to that act, showing us a universe that's not just old but vibrant, complex, and full of surprises. What role do we play in this cosmic drama as observers of a past that shaped our present? The images are a time capsule, each photon a messenger from a universe that no longer exists. They remind us that we're not just looking at space, but at time so deep it stretches to the edge of existence. The galaxies we see may have long since faded, merged, or collapsed, yet their light endures, a testament to the universe's enduring story. What other chapters lie hidden in the cosmic dark? Are we on the verge of uncovering a truth that changes everything? Not just about the universe, but about ourselves? The telescope has opened a door, and the universe is beckoning us to step through. If you're as awestruck by this cosmic revelation as we are, smash that like button and subscribe for more updates from the edge of the universe. Leave your comments below, and tell us what you think these ancient galaxies mean. Are they proof of a faster, wilder universe, or hints of something even stranger, like a multiverse? We want to hear from you. Thank you for joining us on this journey into the cosmic dawn, and we'll see you in the next stellar adventure.